I would say the first thing is that we need to be careful what we mean by learning AI. Because when adults hear the term AI, they often, I think the idea that comes to them is prompt engineering, coding, machine learning, or more very complex kind of technology. But that's not what a 4-year-old should be learning. So when parents ask me how early a child should start learning AI, I usually tell them that a 4-year-old and a 14-year-old should not be learning the same thing. The better question is whether the learning is age appropriate. A 4-year-old definitely doesn't need to learn prompt engineering. A 4-year-old needs to develop curiosity, creativity, confidence, and problem-solving skills. So AI simply becomes one of the tools that support those learning experiences. So in many ways, the conversation isn't really about how early AI should start. It's about what AI learning look like at different stages of a child's development. It will change, the learning journey will change significantly as a child grows. So for younger learners, about 4 to 6 years old, AI learning is often centered around creativity, storytelling, imagination, and exploration, because at that age, children learn best through play-based kind of form of learning, and they are naturally curious and they love creating stories, love asking a lot of questions, and they love experimenting. So for example, many of our younger learners use Scratch Junior, which is a visual coding platform designed specifically for young kids. So instead of learning how to type a code, the kids will drag colorful coding blocks together to make characters move. They can jump, they can dance, they can talk, and then they can interact with each other. So to them, it feels more like storytelling and play, but underneath they're actually learning what is a sequence, how logic, they're understanding cause and effect, and then problem solving. So you are combining all of that skills together with very simple AI tools. And a child might use AI to generate ideas for a story, let's say about a dinosaur visiting the Singapore Zoo, or a rabbit that dreams about becoming an astronaut, or a superhero who helps save the environment. And they will use Scratch Junior to bring all these characters to life through animation. They are not just consuming story, they are creating stories. And that's a very different experience. As children move to primary school, lower primary level, about 7 to 9 years old, we'll introduce them to slightly more advanced and sophisticated projects. So students will begin creating interactive stories, they might start creating games, animations, and do simple problem-solving challenges. And at this stage, they become increasingly capable of connecting the dots or connecting ideas together. And they begin thinking more intentionally about users and experiences. For example, if they create a game, they might be thinking, oh, how would my parents play with this game? So the focus remains highly creative, but the ability to build and express the ideas become much stronger. And because AI can remove many of the technical barriers, children can spend more time refining their ideas and have probably getting stuck. The amount of time that they get stuck will decrease. At this age group, I feel that that's when things become more exciting, because they start creating projects that even their own parents or many parents would never have imagined possible. So at Empire AI, we have had students as young as 10 who are able to build fully functional websites with built-in e-commerce features. And we have had students build language learning applications. We even had a student who create a career simulator that helps users explore different professions and understand the different pathways that lead towards their dream jobs. And what's fascinating isn't just the technology, it's the thinking behind those projects, because really thinking about the end users, they're considering the problems and trying to come up with solutions, and they're thinking about how to take an idea and make it into something real. It's more about the tools that's available to them has actually drastically changed even in the past 1 year. So a few years ago, a child might just have a brilliant idea, but they don't have the technical skills to bring it to life. But as of today, AI tools actually lower many of these barriers, and the result is that students can spend more of the time focusing on their creativity, design, functionality, and problem solving, because instead of spending weeks or months trying to build their version 1, they can start working and improving and refining version 2, version 3 and 4, and that's where I feel some of the deepest learning actually happens. So traditional coding is incredibly powerful. Actually, many of the world's best software products were actually built through traditional code. Traditional coding also requires a significant amount of time before a student or a creator can build and create something very meaningful. Because can you imagine, you have to spend a lot of time firstly learning the syntax, like how I took many years to learn Python, HTML, JavaScript and so on. And then they have to focus on how to debug, how to overcome technical obstacles, and there's value in that process, but it also means that a lot of time and energy is actually spent just to get started. And now with AI tools, vibe coding actually changes all of that, because AI can help accelerate the building process. Something that takes you maybe months or weeks just to create, now students can actually create a working prototype much faster, maybe potentially in just 1 week. And that creates something incredibly valuable, because you have more time to test, you have more time to think about how to refine it, think about integrating user experience, how to make it more perfect. So instead of spending weeks trying to make something work, they can start asking much more interesting questions. How would a user interact with this? They can do more user testing. So after the testing, they can start understanding what kind of features should they be adding, and how can I make this easier for users, and what kind of feedback can I receive? How can I make this better? So this is much closer to how real-world products are actually developed. It's one of the reasons why I'm very excited about vibe coding, because the first version of a product is almost never the best version, because the learning happens through iteration. When a child tests, when a child refines, when a child constantly improves. And because students can get to those stages earlier, they gain valuable experience that previously would have taken much longer to achieve. Teenagers are definitely at the stage where they are more mature and they can tackle much more ambitious type of projects, and that's where vibe coding becomes especially powerful. Students can now create websites, apps, ready-to-market games, productivity tools, business ideas, community projects, so on. So the possibility is now endless. And what is exciting is that teenagers can begin not just thinking about technology, the technical part of things, but also about people. Most importantly, the question is always about who is this for? What kind of problem am I solving? And how would someone use it? How can I improve the experience? And these are very valuable ways of thinking regardless of the career that they eventually pursue. If it becomes a substitute for thinking, then definitely that's not helpful, and that's not what we want to achieve. But if AI is used as a tool that supports thinking, then that is a very different thing altogether, because when students build projects, they still need to make decisions, they still need to solve problems, they have to evaluate and test the output, then they have to use the output to try and improve on the ideas. So all this, AI can help generate the content or the code. But the creativity, the judgment, the direction, all has to come from the creator himself, which is the student. So in fact, many of the most valuable learning happens when students realize that the AI's first answer is never the best answer, and they should constantly try to improve on it. Ultimately, we are not trying to create AI engineers, 4-year-old AI engineers. We are not even trying to create AI. We are not even trying to create software developers. What we are trying to do is to help kids stay curious, creative, confident, adaptable, thoughtful, and we are helping them learn how to ask good questions, explore ideas, solve problems, and create things. Because AI is simply one of the tools that supports all these experiences. A younger child might start with storytelling and creativity, and older child might jump up straight into building their own websites, their own apps, or start vibe coding projects. And the most important thing isn't whether the age that your child is starting at. The most important thing is whether they are being given the opportunities to learn, to create and explore, and I feel that that's what really matters. The most important question isn't whether children should learn AI. The question is how they should learn AI. A 4-year-old doesn't need the same experience as a 14-year-old because the learning should always be age appropriate. But I do believe that helping kids become creators rather than simply consuming is one of the biggest experiences and gifts that we can provide them. Whether it's creating a storybook or animating a character, building a website, designing an app that they feel that community or their friends might need, or developing solution to real-life problem. Those experiences build confidence, and confidence often becomes the foundation for future learning. We'd love to welcome you and your child to Empire AI for a complimentary trial class. Come to and meet our instructors, see what our students are actually building at different ages, and experiment and experience for yourself how AI learning evolves from storytelling and creativity in the younger learners to building websites, building apps, and how they are creating meaningful and useful projects for the community. And this is more applicable for the older students. So sometimes seeing it firsthand is the best way to understand what is possible, because you may be surprised at what your child is capable of creating.